Hi, my name is Catalin. I'm from Pycom. Thank you everybody for attending. I see it's a full house. It's a little bit intimidating for me. I should have put a tie maybe, I don't know. So I'm going to tell you about the PyMesh. I'm going to tell you about the mesh network which is made with LoRa nodes without a gateway. Basically we are using the LoRa raw, the plain LoRa, and connecting point to point, and we're going to create a huge LoRa network without gateways. I'm super enthusiastic about this as I work in the last months exclusively on this in the software development and embedded and a little bit on hardware also. Please stop me at any point if you have any questions. I mean, don't wait until the end. In principle, I made a couple of slides which are going deeper into the technology, how we made this, go deeper close even to the LoRa, and go to all the OSI stack in order to explain you how we accomplish this functionality, the wonderful mesh LoRa. So let me dive in a bit in where we started the mesh development from. So we launched on Kickstarter a product, Pygo, a hardware product, and a mobile application system which is called PyLife, which is as big as, I don't have it with me, I was not allowed to bring it. It's as big as this piece of, it's like a matchbox. It has LoRa, Wi-Fi, Bluetooth, even a little bit of Sigfox we can do with it. We have a version with cellular, with NB-IoT Cat-M1 included. It has an OLED screen, touch areas. We have a multitude of accessories to put it on your bike, to put it on your clothes, to put it on your wrist, with your pets. It has 20, 30 grams, a 400 milliamps battery, which we're targeting for a usage of 2 to 5 days. As I told you, we had a Kickstarter campaign. It was successful, but we got a very good feedback from the industry. There were people from enterprises which actually wanted to integrate this into industrial projects, and for that we made an enterprise cradle, and the device has on the back, the device has IP67, so it's dust and waterproof. On the back we exposed some pins for extending it with additional industrial projects. It's wireless charging also. Internally it's the ESP32, 8 megabytes RAM, 8 megabytes flash. I don't want to bore you with these geek technical details, but stop me at any time if you have any question. We're going to put also an IMU inside, so to detect steps, to detect alarms like people falling and not responding. The user can acknowledge on the touch. And then thinking about the system, we went down into the actual use case scenarios. The scenarios are quite challenging, and they're quite challenging in terms of user enrolling, about authentication, about commissioning, about security, about encryption. These are the chapters that we made some good progress, but I feel that we can do better. I'm going to dive into the technical details and explain you more. So the basic scenario is two people wanted to communicate without having 4G LTE. I know that for people in Europe that's unthink of, because usually the 4G is all over, including rural areas and the top of the mountains. But there are places like Australia, Africa, I guess, where there are these kind of problems. And anyway, the cost of it, I mean, we're not going to, we can look this from a cost perspective. To declutter the 4G, of course, the two users can talk through this whole PyMesh. So if you think of a scale, if you have a mesh network made of nodes which are some kilometers apart, and you can do a chain of, let's say, 60 nodes or 30 nodes, you can see that we can leverage the system for urban areas, for rural areas, and so on. And if we put cloud into the equation of the system, we'll make things way more complex, because we have to think that from the mesh network, the data should travel to the cloud. I guess everyone understands this, because everyone wants to take the data into the cloud eventually. So we can have mixed situation in which our PyGo2, which has the cellular and BIoT, could become like a gateway for the whole mesh and send the data into the cloud. So this is a small scenario with a dog. Of course, the pets losing is a very interesting scenario that we explored into. If we look this, we can look from another perspective, that we can leverage the cellular using the PyMesh. So now, if we go a little bit more into the technical part, the PyMesh is based on LoPy 4. LoPy 4, it's a small board. I have them here. It's a product which was released, I think, a year and a half ago. It has Wi-Fi, Bluetooth. It has LoRa on both 800 megahertz and 400 megahertz, so we have dual antennas. And an interesting thing to point out is the fact that all our products are MicroPython programmable, so the people could just create 5 sockets, and you have data out on 5 interfaces in, I don't know, 7 lines of code. That's an interesting point. I mean, you can quickly, and from this perspective, the fact that we can with mesh offer the same simplicity of creating internal sockets, that makes them very appealing for fast prototyping, for testing some use cases that are, let's say, not well suitable for LoRa 1. More important, where we're going to do the practical part, and I'm going to be back to this slide. The color that is depicted there is exactly the color of the LED from the devices. So the purple one should be the leader, and the green one, this is the purple one, sorry, it's in the back. I didn't even mounted the LoRa antennas. I mean, they're pretty powerful also this way, if I keep them like meter apart. And there's the problem, if the signal is too strong, it saturates. And so if you dive in a little bit more in the PyMesh, of course the implementation was made using the OC layer. Oh, there are people interested by this. I thought I would be. So on the physical layer, we have the raw LoRa. I don't know if you listened the talk of Nicolas Sornin about their improvements in the LoRaWAN stack in order to allow repeaters. I think there are some interesting ideas which can be incorporated into our stack at this layer. Anyway, we personally, in the company, we made some improvements of some of the raw LoRa. We implemented listen before we talk. We used actually a polite spectrum. There's a small document Etsy approved, and they explain why. So a node is like that LoRa 1. It always has to listen inside of the mesh before sending. The collisions are huge. I mean, for 10 nodes, they cannot understand each other if they're trying to talk. Although at every layer, as you know, in the network OC model, it has its own acknowledgement or its own mechanisms for retransmission, for acknowledgement, and so on. So on the data link, we have 802.15.4, which implements an authentication of a key of 128 bits, sorry, not bytes, using IS. It's software implemented, of course, as the LoRa chips. I'm not sure if commercially there are any LoRa chips which implements 802.15.4. We use the 6LoWPAN. I don't know if anyone is, it's IPv6 fragmented protocol. Basically an IPv6 packet, it's as big as 1 kilobyte, maybe more than 1 kilobyte, but on LoRa we are limited on 50 bytes, 100 bytes, 200 bytes. So 6LoWPAN takes care of the data link layer of fragmenting and packing and repacking the packets. We have IPv6. This is a very, very interesting because we have multiple unicast address. We can put, we have groups of multicast, and for instance, if you could have some like routers, you can put them in a certain multicast group and send them some information, like I'm going to change the frequency, I'm going to change the spreading factor. And this information can go only to the routers, and the routers can communicate this individually with their children. And the network would reconfigure itself using these wonderful IPv6 mechanisms. Internally, at the network level, we have distance vector routing, and then we have a certain of the priorities given by the border router. There was one more thing that I want to mention about the internal routing, but I forgot for the moment. Then we have the UDP, only UDP. I think it's good enough. Anyway, I got this from our forum users. In Pycom, we have a huge community. All our software is open sourced. And the first feedback that we got when we pre-released in July was that all this protocol, it's an overkill for LoRa. We're going to, as I said, we're going to release next week the firmware, base firmware for our low-pi devices. Of course, all the code is open sourced, and we're going to release a series of videos and also MicroPython scripts in which we're going to exemplify this, the functionalities. Because it's not that easy even for configuring. I mean, you can make a network of 3-4 devices and look at the console and understand what's happening. But if you want to deploy like 100 nodes, you cannot do this by trying it on a simple. So we have to do some, to develop our tooling environment and to allow something more complex. We are already in the process of that. I can show you a simple development mobile application on which I personally developed the mesh, and I can walk around the city and understand how our nodes talking with each other, what is the RSSI. Now I remember what I wanted to tell you about the network level, about the distance vector routing. This is based, of course, on the RSSI, on some link cost between the two adjacent nodes. Of course, I can show you some more advanced features. A network itself could split in partitions. There are situations which a network could become too complex, and not too complex as number of nodes, but the protocol above, the application protocol, could become a little bit too heavy, and to maintain 10 nodes, it's far more easy than to maintain 30 nodes. So the network could split itself, and if the situation or the radio conditions improve, it could merge itself into a single mesh. About the power consumption, I got yesterday on the stand lots of questions. That's why I said I should tackle it here. Of course, it's quite challenging because being in the mesh, we should not miss for packets, but in the same time, we have to have a power consumption which fits for the use case scenario that we want to use our system for. For this, I've prototyped a mesh network of around 20 nodes, in which I put the nodes in deep sleep. I mean, not even listening, not even on LoRa, 7 times more than being them in the normal. and the results were pretty encouraging. I mean, they could still survive. So with this, we can take the power, the system power consumption pretty low. I mean, we're targeting, like we said in the Pygo, 2 to 5 days, 400 milliamps battery. And about the radio duty cycle, as I got yesterday, lots of questions. A node is not doesn't talk a lot. Now all the internal parameters of how often the nodes are keep alive or are sending packets are completely configurable. So now with a keep alive packet sent around 30 seconds, every 30 seconds, and with a protocol which we can consider like sending some messages, some spurious messages, taking some temperature data and sending every minute or so, we can keep it the system overall duty cycle within the 1% limit. I cannot show you exactly, so first of all we can scan all the Bluetooth connections, then we can connect to one of them, let's say Mr. number 10 from here. We can inquire information like his IP, and he's going to tell us at some point. I don't know. The application itself has some issues because it was for iOS and Android developed, and it has some BLE issues. No. Maybe the Bluetooth spectrum is a little bit occupied here at the conference, I would say, with so much Wi-Fi, and we didn't connect it. Any other question meanwhile? I was about to send you to tell you also that we have some CLI commands, so you can play with them and send message from a node to another node specifying just the MAC address, and you'll receive the acknowledgement. We have this already implemented in the PyMesh protocol. For anything, visit our forum at forum Pycom IO, or drop me an email directly at Catalin at Pycom IO. Okay, thank you very much.